All right, finally, we are on to chapter 2. All right, so here's section 2.1, part 1, where we're going to talk about power and radical functions. Okay, so the essential question for this particular section is, what are power and radical functions? So what we're going to learn in part 1 is how to graph and analyze power functions. All right, so we have to figure out what a power function is to begin with. So a power function is any function of the form f of x equals ax to the n, where a and n are non-zero real numbers. So they can be any number you want as long as they're non-zero. So for instance, f of x equals, let's say, 3x to the fourth. That is considered a power function because the 3 is your a, the 4 is your n, and they're not equal to 0. Okay, so that's what a power function is. Okay, so there are different types. Okay, so let's look at the top set here. If your n is even and your a is positive, okay, so y equals, if your a is positive, so let's just say 3, and your n is even, so give me an even number, let's just say 4. Okay, so if you have something where your a is positive and your n is even, it's going to look like something similar to a parabola. Okay. Now, on the other hand, if a is negative, so negative 4, and your n is even, so x to the second, it's going to be flipped upside down. So remember, we know that if you put a negative in front, it's going to reflect it over the x-axis, so it's going to look like that. Okay, and all of these properties are true. Domain, range, all of these properties. So the domain of this would be negative infinity to infinity. Range would be 0 to infinity. This one would be the range would be negative infinity to 0. Okay, they're all continuous. Okay, so they're symmetric about the y-axis. You can flip them over the y, and they're still the same on both of these. They increase in certain spots. Okay, all of these properties hold true if these circumstances are fulfilled. All right, now let's go down to the bottom here. So remember, we have y equals a x to the n. Okay, so if our a is positive, so y equals positive 3, and our n is odd, so let's say I don't know, 3. 3 is not a number, so 3x to the third. Okay, it's going to go up on the right and down on the left. So it's going to go up on the right and down on the left, and it's kind of, and I always call these sideways s's. It's going to have this sideways s shape. Okay, now if your a is negative, so negative 3, and your n is still odd, so we can do 5, negative 3x to the fifth, the left side is going to go up and the right side is going to go down. Okay, so the question is, can we answer all of these questions for these particular problems? Can we state the domain and range? Can we state the y and x intercepts? Is it continuous? Okay, things like that. So those are things we're going to learn how to do. Okay, so we need to learn how to graph these. All right, so let's see here. So our function is y equals, okay, it says graph and analyze each function, describe the domain, the range, the intercepts, behavior, okay, different things like that. So our function is y equals 1/2, you can use 0.5 if you want, x to the fourth. Okay, so our a is positive and our n is even. Okay, our a is positive and our n is even, so it's going to look of the form of like a parabola. Okay, so now what is the quick way to do this? Okay, you have a calculator. Let's use it to our advantage. All right, so let's plug this equation in. So y equals 0.5 x raised to the fourth. Okay, and we can see the graph. Now, that's not going to do me any good. This graph on the screen does not do me any good. I need to go to the table. Okay, so I'm going to make sure my table is set properly. I'm going to start it at 0, and I'm going to go by ones. Okay, so you can see I have x values in here. So let's go to our table. So my first x value I have is negative 3, and you can see negative 3 goes to 40.5. Okay, so negative 3 goes to 40.5. Now what about negative 2? So negative 2 is equal to 8. Negative 2 is equal to 8. Negative 1. Okay, so negative 1. What do we get when we plug in negative 1? Negative 1 is equal to 0.5. So 0.5. 0. What's 0 to the 4th times 0.5? That's going to be 0. And then all of these numbers, since these are symmetrical about the y-axis, all of these numbers are going to be the same. So positive 1 is going to be 0.5, positive 2 is going to be 8, and positive 3 is going to be 40.5. Okay, and so what do? Plot the points. Okay, we're going to graph these just like we ordinarily would. So 0, 0, I'm going to start with 0, 0. 1 is 0.5, so kind of right here. Negative 1 is also 0.5. 2 is equal to 8, which is way up here. Negative 2 is equal to 8. And then notice, though, okay, we have negative 3, 40.5, so it's way up here off the screen. I'm not going to graph that. Now, you could graph that, change your scale, but I'm not going to do that. Okay, so I'm just going to draw in my shape here. It's really hard to do with this tablet, so hopefully this looks okay. Okay, and did it look like what we just said it did? Yep, it did. It does. Okay, so you need to be able to state the domain, the range, the intercepts, end behavior, continuity, things like that. And I think that's pretty standard now. So for instance, I'll just run through a couple here. What is the domain? So starting from the left, it's going from negative infinity to all the way to a right arrow, which means positive infinity. What is the range? So going from top to bottom, so it starts at 0, it touches at 0, so it's got to be closed, and it goes up forever. So it's going to go to positive infinity. Okay, let's do a little bit of end behavior. The limit as x approaches infinity. Okay, so as the x are getting bigger, what's my y doing? You can see it's going off the screen. So f of x is equal to positive infinity. It's going up off the screen. Let's do the other direction. What happens if we are taking the limit as x approaches negative infinity? Okay, so that's the other direction. As x is getting smaller, what's my graph doing? It's also going up and off the screen. So f of x is equal to positive infinity as well. Okay, it's continuous everywhere. It's decreasing from here to 0 and from 0 to infinity. Okay, so those are the things that you need to be able to state and graph properly. All right, let's look at example 2. So this one is y equals negative x to the third. This one's a little bit easier to do. So our a is negative and our n is odd. So our a is negative, our n is odd. So let's find that on the chart. A is negative, n is odd. So it should look similar to this one. All right, so let's see what we get here. So we can use our calculator again. So y equals negative x raised to the third. It's now the 34th. Delete. All right, so I'm going to go to second table. We're going to start at, we can start at -4, but as long as you're going by ones, that's what you want. So second graph, table. All right, so we're starting at -3 again. -3 is equal to 27. 27. -2 is equal to 8. -2 is equal to 8. So this should make sense. So let's think about this. -2 cubed with a negative on the outside. -2 times -2 times -2 times -2. So that is equal to negative times negative is -8. But then we have a negative on the outside, so -8 turns it into a positive 8. All right. So what about -1? -1 is equal to positive 1. 0, 0 cubed is 0. So 0 is 0. And then let's see, 1. Okay, let's go to our calculator. What is 1 equal to? 1 is equal to -1. So this is a little different than the last one. What's 2 equal to? 2 is equal to -8. And I'm assuming you can see the pattern. Positive 3 should be equal to -27. All right, so let's graph these. So we have 0, 0 again. We have 1, 1. We have we have 1, -1. My fault. I should follow an order here. So 0, 0, 1, -1. 2, -8. So 1, 2, 3, 4, 5, 6, 7, 8 down here. I'm going to skip the next one because it's way down at -27. I'm going to do -1, positive 1, -2, positive 8. And you can see the shape that we have. Okay, so does that make sense? Hopefully that makes some sense. All right. so that is our sideways S function. Okay, and same thing, you should be able to tell me the domain, the range, the discontinuity, the same things that we did in chapter 1 still apply to these new functions that we're learning here, power functions. All right, so the last part of this particular section, it says recall that if f of x is equal to 1 over x, or x to the negative first, so remember the negative exponent rules, x to the negative first is equal to 1 over x to the first, so these two things are the same thing, are undefined. So 1 over x are undefined at x equals 0. That would make sense, right? Because if I plug in 0 here, 1 divided by 0 is undefined. That doesn't work. So this equation is undefined at 0. Similarly, if f of x is equal x to the negative second, so 1 over x squared, or 1 over x cubed, they are also undefined at x equals 0 because 1 over 0 squared is still equal to 1 over 0. That's still undefined. 1 over 0 cubed is still 1 over 0, which is undefined. Okay, so anytime you have one of these negative exponents, okay, so if you have one of these negative exponents, it's always going to be undefined at 0. Okay, doesn't work. Okay, 1 over 0 is always going to be undefined. Because power functions can be undefined when n is less than 0, the graphs of these functions will contain discontinuities. Okay, so as long as our n, so y equals ax to the n, if n is less than 0, it's going to be discontinuous. Okay, so let's look at an example. All right, so we have a negative exponent here. All right, so I'm going to go into my calculator now. I'm going to go to y equals 3x to the negative second. Okay, not worried about the graph. I want to go to the table. So table. All right, so we're starting at -3 again. If you see -3 is 0.3333. So here is 0.33 repeating. All right, what about -2? -2 is equal to 0.75. So -2 is 0.75. What about -1? -1 is 3. -1 is 3. 0, what do we get when we plug in 0? 0 is an error. Remember, this is equal to y equals 3 over x squared. Okay, remember, negatives go to the bottom. So if I plug in 0 for x, that's 3 over 0 squared, which is 3 over 0, which is undefined. Okay, so 0 is going to be undefined. All right, let's see what 1 is equal to. See if this is symmetrical. 1 is equal to 3. So it is symmetrical. So 0.75 and 0.33 repeating. All right, so let's plot these. All right, so let's start at -3. -3 is 0.33. 1, 2, 3. And 0.33 is right here. Okay, sorry, I have an annoying cat. All right, so let's plot this again. All right, so we said -3 is 0.33. -2 is 0.75, so a little bit higher. -1 is equal to 3. -1 is equal to 3. Okay, 0 is undefined, so there's nothing here. 1 is equal to +3. 2 is equal to 0.75. And 3 is equal to 0.33. Okay, so you can kind of get the general idea here. I did not do a good job graphing that, so I'm going to start again. All right, so we have this, and I'll try this one over here. But please remember that the graph is undefined at 0, so it gets really, really, really close, but it never touches any of your axes, right? So once again, we should be able to find the domain, find the range. Okay, is it discontinuous, continuous? Where is it increasing? Where is it decreasing? And we'll go through all of these in class when we get back. We'll look at this graph and then we'll go through these different analyzing that we have to do: continuity, increasing, decreasing, and behavior. Okay, hopefully that makes sense. These are power functions. The next section we'll be talking about radical functions and some power regression curves that we can do on the calculator. Have a good night. See you tomorrow.